can only form from a collapse of a star, which originally should have had 30 times the mass of the sun. Okay, and this is what it will look like. You have this blue giant, and and this matter is coming through. It is filling what we call Roche lobe, which is a black hole, and because angular momentum conservation has to be maintained, it doesn't directly to this. In the center and produce this enormous X-rays and energy, but it forms a little disk. This is a common thing around every black hole, and because there'll always be a disk around which is formed due to conservation of angular momentum, and then from the inner part, the disk, the matter flows onto the black hole and produces energy. This is the most efficient way of producing energy, so more efficient than nuclear fusion, which is only 0.7 times the rest mass is produced. In here case, you can produce something like 20-30% of the rest mass can be converted into luminosity and so on. And this actually led to a bet because Hawking was still not convinced, and Kip Thorne, who got a Nobel Prize 2 years ago from the use of laser interferometry for finding the gravity waves, they took a bet, like a subscription to some magazines of their liking each and so on. And finally, in '74, Hawking conceded the bet to Kip Thorne. Kip Thorne has a beautiful book on black holes, which if you get a chance to read it, and so on. So Hawking lost the bet. He said no such a thing doesn't happen. There are no black holes, and so on. At that time, he was later convinced that there is sufficient evidence. Okay. Today, we know there are about 20 such black holes in our galaxy, which are confirmed. And there are 59 candidates which people are studying, and people estimate there will be around 1,300 such objects within our Milky Way and so on. So these are what we call stellar mass or solar mass, that is few times the mass of the sun. These are not supermassive black holes. Okay, so what are supermassive black holes? This I already pointed out. The Schwarzschild radius is proportional to mass and therefore its volume. The physical radius is proportional to the cube root of its volume. So, I just inverted that. Now, so if a body accumulates matter at a given fixed density, let's say the density of a water, its Schwarzschild radius will increase much more quickly than its physical radius. And when a body of such a density has grown to around 136 million solar masses, its physical radius would be overtaken by Schwarzschild radius. So Schwarzschild radius is now bigger, the body is inside. So the body is gone inside the Schwarzschild radius, kind of a singularity, and thus it creates a supermassive black hole because now the trapped surface has grown beyond the physical size and so on. So this is how you can actually think of making a physical black hole and so on. So the problem is, in stellar mass black holes, we know that if a supernova explosion happens, we would be able to, quickly see them and so on through binaries, etc. And we know how they form through explosion. These supermassive black holes, we have no idea how they form. We think that there is a collapse of a star or a few stars and so on, and then it starts attracting and pulling together other smaller stellar-sized black holes, like we have this 1,300 in our galaxy and so on, and then it will slowly grow and become million to a billion solar masses and so on. Okay, so this is all we know about supermassive, but these are the most common and seen everywhere and so on. And these are actually there. People didn't recognize them. So there's a gentleman known as Carl Seaford, and he had already discovered the first supermassive black holes before this '63 discovery by looking at some galaxies where he found that there is a star-like nucleus, and the nuclear emission from that star-like nucleus in the center of the galaxy is much larger than the entire output from all the stars in the galaxy by orders of magnitude. again. So you have a high luminosity object sitting in the center, and it is not a star. It looks like a star, but does not have the spectrum usually associated with stars and so on. And people are studying these things. So this is the way he discovered old time, when there were no digital devices, no CCDs like you have in your phone cameras and so on. What people used to do is take exposures on photographic plates at different times and so on. So here you take a snapshot of this object and you see this, just the nucleus. And then you make the exposure slightly longer and develop the plate again, a film, and you go on increasing, and then you see that actually this is a galaxy. But you could see the nucleus, but you had to take very, very long exposures to find these faint objects and so on, and then actually understand that this is a nucleus of this galaxy and so on. So this things have improved a lot after digitization, and when you have charge coupled devices come into the in everyday use, and the people started to use them in 17s, and today we actually fly them on satellites. So here I'll show you a picture of the same galaxy taken with our Indian satellite, Indian space first Indian space observatory called Astrosat, which Professor Tripathi mentioned. And so here is the near ultraviolet image taken with this observatory using a digital camera at the focus of a telescope with now, and you can see both the nucleus and the galaxy together, because here you can change the dynamic range. You have a huge dynamic range in these devices, so you can see all these things and so on in UV, FUV on the same galaxy and so on. So and you can see the spiral arms and everything, etc. But the 63 discovery actually was objects like this 3C273. Okay, this is actually an X-ray image taken with the NASA satellite Chandra, and you see a very luminous object, and very, very large luminosity, which is about 3 billion light years away, and is a QSO or quasar, and it's given the name as Third Cambridge Catalog 273. So it was discovered as a radio source, then dished out and so on. X-ray I was showing you earlier, imaged I showed you visible, now X-ray. Okay, or the X-rays are coming only from the center and the huge amount. So it is kind of X-rays are a very powerful way of finding these objects in the universe and so on. And the radio, you see the arms which coincide with one of the rings you saw in the spiral arms and so on. And then you have also a radio galaxy. This is known as Hercules X1, and this is closer to us. And you see jets coming out on